Okay, introduction to functions. Right, let's have a look at this table. Okay, now this table, the time of day versus your body temperature. Now let's have a look at the graph this has come from a previous video, just earlier in the book. Look at that. Okay, so a lot of marks on here, but what I'm trying to point out here is, okay, at 1 AM, let's have a look, my body temperature was 98.1. So I wrote it there. Let's look at 7 AM. Was it 96.3? Right, here's 7 AM right here. Okay, so 7 AM, and that is 96.3, and so on. So I'm just reading all these marks and me just reading from the graph, putting it onto this table. Okay, so what this kind of question below is trying to ask: how many temperatures are assigned to any one particular time? All right. Now remember, time's the important thing. This is the x-axis. That's the input. What I put in, what do I get out of this? I get a body temperature. Okay, that's just kind of like the answer. So x-axis the time, y-axis the temperature. Now then, can you see? I'm only going to get one temperature for a certain time of day. Here we go. At 1 AM, I'm 98.1. I can't be 98.1 and 99.1 at the same time of day. I can only be one specific temperature. Okay, but so that's what it's kind of trying to ask you. Okay, there's only one specific temperature for one particular time of day. And if I read down here, it's an example of a function. This is a function, okay, because for any time of day, there is one and only one corresponding temperature. So the temperature, the output, is a function of the time of day. Okay, so the temperature depends on the time of day. The time of day is the important thing, the input. But have a look at this. Okay, so remember I said only one temperature for one time of day. But let's have a look at the graph again. At 4 PM, an extra one I've put on here, I read up here, 4 PM, I read, oh, I'm also 98.1. Let's have a look at this table. Yeah, right. Let's have a look at this then. Okay. Now can you see? I can only have one time of day producing one specific temperature. Okay. So at 1 AM it can only be 98.1. It can't have two different temperatures. But two different times of day can have the same temperature. That makes sense, doesn't it? My body temperature can be 98.1 at 1 in the morning and 4 PM at night. Okay, so look at that. So can you see that that same temperature can come from two different times of day, but one time of day can't have two different temperatures. Okay, so I mean that kind of makes sense, but this is me saying why this is a function. It's okay to have those two same body temperatures for two different time of days. Okay, that's okay. Now let's have a look at some definitions then. Right, here it is. A function relating input to the output in such a way that assigns only one output value to each input value. There's only a unique answer. Again, at 1 AM, I'm only 98.1. I'm not two different temperatures. Okay, let's have a look at some more examples. Right, distance from home over a 9-hour period. Right, we're driving away from home. Okay, I put some marks on this already. After 1 hour, I am 50 miles away. At 3 hours, I'm 100 miles away. Okay, here we go. Let's get an arrow going. So at 3 hours, I'm 100 miles. At 4 hours, I haven't moved. I'm still 100 miles away. Okay. After 8 hours, I'm driving back. I'm 50 miles away again. And at 9 hours, I'm at home. I'm at 0 miles away. I'm at home. Now again, can you see? Okay. So after 1 hour, I can only be 50 miles away. I can't be 50 miles away and 100 miles away at the same time. But it's okay to be 100 miles away here from two different times. Okay, again, after 3 hours, I'm not moving. I'm 100 miles away. I'm at my friend's house. After 4 hours, I'm still there. I'm having a nice cup of tea. All right, I haven't moved. It's okay to be the same distance at two different times. But the same time can't have two different distances. Have a look at some little explanations on this. Right, at 1 AM, okay, I cannot be 50 miles away. This makes no sense. And 100 miles away at 1 AM. That's ridiculous, okay? But at 1 AM, I can be 50 miles away, and at 8, well, I don't know about the time, 8 hours, okay? I can be, that's okay. Look at the visuals on that, okay? At 1, I can't be two different distances, but these two different times, I can be the same distance away, okay? After 1 hour and 8 hours, I can be 50 miles away. That's okay, okay? So this, again, that's ridiculous, okay? Right, so is the distance from home a function of the time? Yes, it is. There's only one unique answer. After 1 hour, I'm 50 miles. After 3 hours, I'm 100 miles. After 4 hours, I'm 100 miles. That's okay. It's not after 4 hours, I'm 100 miles and I'm 50 miles away. Makes no sense. It's okay. There's only one answer for that 4 o'clock, or 4 hours. Now then, let's have a look at this. A roller coaster. Now then, this looks like a roller coaster, but it's not a function. Now I know it's going to ask you, is the right height a function of the distance? Well, it's not, and I know from the visuals there's a very good shortcut for this, which I'll show you in a little bit, but look at this. Right. Okay, I've travelled, say, like 10 metres away from the start. I'm that high up, alright? I've travelled, let's say, 80 metres away from the start. I'm this high up the roller coaster. But look at this. Say I'm 100 metres away. 100 metres, okay? Okay, we go. How can I be at the same distance, all right, or even at the same time, how can I be this height, and this height, and that height? How can I be 3 different heights at the same point away, all right? Or the same time away, all right? So here I am, I've moved over here, I'm not here, here, and here, okay, 100 metres from the start. That makes no sense, okay? It's going back to up here. You know, I can't have this. At the same time, this is time this time, I can't be 2 different distances. Well, at the same point away from the start of the roller coaster, I can't be 3 different heights. Now watch this right now. Oh, here we go. Look. If I put a line right through here, it only hits the graph in one place. Over here, it only hits the graph in one place. Here, I'm hitting the graph in 3 different places. This is called the vertical line test. And visually, it will show you that this is not a function. It doesn't pass the vertical line test. Let's have a look. Over the next slide. Here it is, vertical line test. If a vertical line is drawn through the graph and intersects at no more than 1 point, then it's a function. Okay? Or if there's a single line intersects the graph more than once, it's not a function. Okay? So let's have a look at some examples. That's a function. That's not a function. Look, 1, 2 places. Here, 1, 2 places. Not a function, okay? Next slide. Okay, here. That's okay, that's okay, that's okay. Not okay, okay? Again, 2 places. Now, again, to explain this more like algebraically and graphically all at once. Okay, this, whether you need to know it or not, that's an x squared graph, okay? This is the x squared graph. Y equals x squared is the equation, okay? Right, how about this? When x is 2, here we go, here's x is 2, right? Here's x is 2. Right, if I put 2 and I square it, x squared, y equals 4. Here we go, 4, there we go. Okay, so y equals 4, right. Now when x equals negative 2, okay, over here, well, negative 2, if I put that here as well, if I put that and square negative 2, I still get y equals 4, don't I? Okay, still get y equals 4, and there it is here. So there it is. Okay. Now, it's a function. It's okay. Visually, it's a function. It's going to pass the vertical line test, okay? Put a line through anywhere, only hits it in one place, okay? But again, it's going back to the fact that I can have the same answer from 2 different inputs. I can't have different answers from the same input. If I put 2 into that equation, I'm going to get 4. I'm not going to get 6 as well. 2 squared is 4, it's not 6. I can't have 2 different answers. Let's go back and look at this again. Here we go. 2 plus 3 equals 5. Yes, of course it does. Wait a minute. 4 plus 1 equals 5. Well, yes. Well, look, I've got the same answer, haven't I? But from different inputs. Same answer. Well, I can't do this, can I? 2 plus 3 equals 6. No, of course I can't. I can't have 2 different answers, okay, from the same input, okay? You can't have 2 different answers from the same input. It's okay to have the same answer from different inputs, okay? So again, if you look at this, 1 o'clock, I was 98.1. I wasn't 96.3 as well. That makes no sense, okay? Let's erase that. I can't have two different temperatures at the same time of day. Right, at 7 a.m. I was 96.3. At 1 p.m. I was 97.1. I'm only getting one answer for any particular time of day. But look at this. This is okay, isn't it? Of course, yes. That 98.1 is only one answer for 4 p.m, but it's also for 1 a.m. I can be the same body temperature at different times of day. I can't have two different body temperatures at the same time of day. Okay, so that is perfectly okay. Same body temperature, two different times of day. Of course, it makes sense. Okay, so that's you looking at functions, and I think that was everything. Okay.